Hi everyone, this is Umamaheswarareddy Chintam. I'm a solution architect. Welcome to the conference. And today's topic is powering AI enhanced cloud native integrations. This talks about the performance statistics of AI enhanced cloud native integration platforms. And also we learn about the practical implementation, strategies that improve efficiency, security, and reliability across your enterprise systems. We'll go to this PDF and we will talk about each slide in next few minutes. First topic I would like to cover is performance advantages, efficiency model, memory efficiency, fast compilation, and static typing. In concurrency model, the Go lightweight enables the highly efficient parallel processing with a minimal overhead. This model effortlessly handles thousands of simultaneous connections while maintaining the consistency of the performance side. Then we'll go with the memory efficiency. This mainly focuses on the garbage collection algorithms where it dramatically minimizes the memory footprint without disrupting the operations. System resources remain optimally allocated even under extreme processing loads. In case of fast compilation, it is almost like near instantaneous build cycles significantly accelerate the development process. Engineering teams can rapidly iterate through complex integration challenges with the minimal wait timings. Static typing enables compile time error checking, sustainably reduce unexpected runtime failures in production systems. Mission critical enterprise system maintains exceptionally uptime and reliability. By having this, what is the real-time impact for your enterprise applications? It reduces the 25% of the deployment period where the microservices architecture slashed its deployment cycles by a quarter percentage compared to its old legacy systems just by and also it helps to bring fast to market of their application. In case of reliability improvements, this Golang based approach helps 30% fewer critical incidents with a significantly reduced mean time to recovery. It also supports in multi-cloud and also reduces 23% of its time for any concurrency model, which is optimized to reduce resource utilization across different providers and infrastructure costs. Okay, now let's go to how this AI enhanced integration helps in different phases of your deployment or development, and even support as well. First topic we cover about like what is automated data mapping. A Go-powered AI framework have slashed manual integration efforts by 25%. These intelligent systems analyze complex data structures in real time and generates optimal mapping without human intervention. However, in the background, it helps is like it identify all the existing or across the world similar kind of patterns for each data node level and brings down your entire efforts by 25% by providing the existing by leveraging the existing mapping structures across the landscape. Your application it's going to read the backend, okay, each node level, identify, okay, this is close to this one like that. So this gives you reduce the time by 25%, which is a very significant change when it comes to mapping level. Okay, let's go to the intelligent error handling. Advanced AI models nowadays it anticipates integration failures before they occur. These proactive systems automatically implement self-healing protocols and dynamic adapter to changing operational conditions. Next opportunity, accuracy improvements. AI-driven transformation engines have delivered a remarkable 30% improvement in data accuracy, where it has various sophisticated patterns which recognize and also recognition algorithms identify and prevent potential quality issues before they impact operations. Let's go to the next slide. What are the performance or this platform benchmark comparison between different integration applications like CPI, SAP, MuleSoft, Apache Camel, and Go-based solutions. Here, mainly, if you see the dark color, which is a performance score, and light color is the resources efficiency. In all these aspects, mainly we notice Go-based solutions always dominates or gives better results in both the metrics. It always like significantly outperform where you have the traditional integration platforms or enterprise benchmarking also reveal that our Go-based solutions deliver up to 32% higher performance scores and 34% better resource efficiency compared to legacy systems. These impressive gains translate directly into reduced infrastructure cost and improves scalability, also enhance responsiveness for your mission critical integration flows. The another key topic which I would like to cover today is security. Mainly four phases. One is identifying threat detection, analyzing the threats, responding to your threats, and the learnings. Okay. Threat detection. Okay. In any security, first you need to have your threats to be identified. Our robust security libraries implemented sophisticated patterns to recognize threats using algorithms, plus access pattern are identified and flagged in real-time microsecond precision. Once you identify the threats, then we analyze. Okay, we have advanced machine learning models evaluate that vectors using contextual intelligence. This sophisticated approach has reduced a false positive alerts by 23%, minimized the security fatigue. Response. Precision engineered countermeasures deploy with sub-second latency, compromise systems automatically implement isolation protocol to prevent lateral network traversal. What are the learnings? Every security incident enhances future decision capabilities by 27% through reinforcement learning algorithms. The system continuously evolves its threat intelligence database that will help next identify the next threat detection pattern. Now we'll go to the edge computer integration. In this integration world, you have to have your data to be collected from various IoT sensors, real-time field data. Once you have the data collection in the local itself, you identify local runtime executes the optimized edge analytics. Once it enriches based on embedded machine learning models and understands its contextual understanding. Then we'll go to the cloud synchronization. After having AI enrichment, the filtered data transmits securely into the cloud infrastructure where the insightful distribution will come, which has actionable intelligence device, generates decisions, whether how it takes. This is all microservices based communications, analysis, processing, enrichment, syncing with cloud. Then it goes to the distribution. Our lightweight runtime and concurrent processing capabilities revolutionize edge computing integration with sophisticated AI capabilities. This implementation has demonstrated reduced data processing latency by 18% while decreasing cloud bandwidth consumption and storage overhead by 15%, delivering substantial operational cost savings and performance improvements. DevOps tooling improvements. You have mainly automated pipelines. We have mainly with Go in the Go. We have powered with CI/CD pipelines, which reduces the deployment time by 40%, while validating the integration points with a 99.8% accuracy, which is close to 100%, which has a seamless deployment occur without human intervention, eliminating most of the manual errors. Intelligent testing. Machine learning algorithms identify and prioritize critical test scenarios with 87% greater efficiency Also, these testings coverages strategically focus on high-risk integration points, which reduces the overall testing time by 35%. Once the testing is there in the production system, you have to have a product proactive monitoring. This advanced anomaly detection identifies potential issues 50 minutes before their impact. Our system initiates automated resolution protocols for 73% of instances before operational disturbance. We have mainly four different type of implementation patterns based on APIs. API gateway pattern, where Go functions has a high performance and resource efficient API gateways that intelligently routes, request orchestrate services, and implement robust authentication with minimal computational overhead. Here, this is the main thing. The next one is event-driven architecture. The Go concurrency model with the channels creates sophisticated event processing pipelines, enabling seamless communication where distributed system responds dynamically that changes the state across your integration platforms. And the sidecar pattern is something like it's like very close to legacy related things where you keep Go services operate alongside your companion processes and also introduced advanced AI capabilities, enhanced functionalities without requiring modifications to your legacy data code database where we keep running that one and parallelly you go and develop Go services based integration approach. Next one is triangular fit pattern. In this, Go implementation incrementally replaces your legacy integration components through interception points, facilitating non-disruptive migration while maintaining the system stability and integrity throughout the transformation process. Yeah, it has every pattern has its own advantages based on our enterprise application integrations current approach and the best of the best Golang architecture. We will find out which one is going to useful while implementing this. Okay. What are the success metrics? We saw 22% higher success rate in enterprise integration initiatives that we completed, mostly in on and within the budget. 30% deployment efficiency. It accelerates continuous delivery pipelines with fewer roadblocks. 25% less manual work. Intelligence automation eliminates repetitive integration topics. That reduces your manual work by 25%. At the same time, 30% improved accuracy, what we observed. Okay, what happens when you are doing this less manual work and automation? That improves the accuracy to reduce any errors while doing the APIs across your system boundaries. 18% reduce in latency. When it all these measurements, you have improved accuracy, deployment efficiency, and all these points, automatically it reduces communication latency by 18% for all your mission critical transactions processing. Organizations implementing Golang based integration platform consistently achieve a measurable improvements across all key different indicators, resulting in substantial return on investment and competitive advantage in their digital transformation initiatives. How we implement, just to give you the roadmap, first we assess that where we conduct a thorough analysis of your existing system and performance bottlenecks. Then we map specific business processes that would benefit Go concurrency model. We may not go to every point needs to be replaced, but we can definitely suggest what are the benefits by doing this. Then we can implement pilot project where we develop a targeted Go microservice with clearly defined boundaries, select a high visibility integration pattern challenge, and to demonstrate measurable improvements. Framework deployment, development, and deployments. In this, established standard Go design patterns and reduced components, we engineer robust connectors for mission critical enterprise systems and data sources. Then we can scale up the deployment, strategically expand Go implementations across the integration landscape, implement comprehensive metrics to quantify performance gains and return on investment. These 4 steps gives confidence to customers and which is a very targeted approach where we can eliminate a lot of overhead on the customer by using the said security measures and approach of the development, all the things. Thank you for your time. I'm open to all the questions. Have a nice day.